Welcome to CST release question number 7 for Algebra 2. It says which point lies in the solution set for the system, and you have two inequalities here, 2y minus x greater than or equal to -6, 2y minus 3x is less than -6. So what we really should do on this one, well, we can do a couple different things. I'll show you how to do this if the answers weren't there and you wanted to know what it looked like exactly. And we can also talk about, seeing it is a multiple choice test here, a multiple choice question that we're going through. Yes, we could plug these values in and see which one works. So I'll talk about both ways, but I want to show you the way to actually show the whole solution set for something like this, and then we'll talk about plugging in answers from there. So I'm going to use my nice line tool to make a really nice looking graph here. Take that. There we go. I like it. This is going to be my y-axis, of course, and my x-axis right there. So I'm going to start graphing things, but after I get both of these into slope-intercept form. So it's, I think, easiest. Yes, you can use x-y tables to graph stuff like this, but I think it's easiest to use slope-intercept form instead. So I'm just going to rewrite what's there and then start working it out from there. So I want to get y by itself on one side. To do that, first step would be to add x to both sides. That would give me 2y is greater than or equal to. This cancels. You've got x minus 6. And if I divide everything by 2, think of that as like 1x minus 6. And we would have this canceling right there. Y is greater than or equal to 1/2 x minus 3. So we can graph that now to start. We've got a y-intercept right here at -3, so that's a point right there, and we have the slope of 1/2. So we go up 1, right 2. If you ever see, I like to talk about Super Mario Brothers, the original Nintendo game, where Mario, he was always moving from left to right, and if you have a positive slope, Mario should be always running uphill. And when you have a positive slope, remember you couldn't go back in Mario 1 in those games. You know what I'm talking about, right? You got the little Goombas right here. Those little dudes they did nothing, but occasionally you would land on them. You got Mario, Super Mario Brothers, with his mustache going here, and dun 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 dun, and you'd have these little steps like this. Look at that. That's a positive slope because he's going uphill right there. Positive slope. There's our bell. No, you can't leave your chair right now yet, or wherever you are. So uphill, positive slope. If he was going like this, think going downhill is a negative slope. So negative slope, positive slope, going uphill. So this is a positive slope running uphill as you move left to right, and that pattern is going to continue like this, 1/2, 1/2, and so on. If you went the other direction, -1, you'd go to the left 2, because -1 over -2 is the same as +1 over +2. So I'm drawing a bunch of different points on here. I don't really need to draw this many, but I just felt like drawing that many. So I'm going to connect now these with as straight of a line as I can, freehand. I should maybe just get my straight line tool out, but I think I got this. All right. And notice it is a solid line because this is less or greater than or equal to. If it was just strictly greater than, this would be a dashed line. And now think about this as kind of being a roof again. I like using that illustration or analogy. If we have stuff that's or equal to, it's going to be solid line. And if I'm talking greater than or equal to, we should shade above, because I'm shading above the roof, I want to say. So a shade above the roof. Think of this as the roof to a house, and we're going to be shading above then. So I have everything above here. I'm going to put that in my red here. So I'm shading above that line. So right now, this would be the solution set to just that specific inequality. But I want to know the solution set to both. And so now in green, I'll tackle this one. So down here, let's rewrite it. I've got 2y minus 3x is less than -6. And I would be adding 3x to both sides. dividing everything by 2 from there. That canceled. Divide by 2, that'll cancel, but divide everything by 2 then. And I'll have y is less than. Notice no dividing by negatives, so I did not flip the sign in either one. But I've got 3/2 x minus, this would reduce down to just plain old 3. So I have minus 3. So here now, I'm using this. I used this one before. This is telling me how to shade and what kind of line. So no or equal to part here. This is going to be a dashed line now. And we have stuff that's less than, so we're going to shade below in this case. If it's greater than, shade above the line. If it's less than, shade below the line. And so from there, we've got an intercept. This is my y-intercept at -3. So would you look at that? Ooh, it's right at the same spot. But we have 3/2 x. So now we're going up 3. Think of this as your rise. Rise, think of the sun rising, going up and down. So up 3 and right 2. You have another point. Notice it's positive. So, yep, Mario analogy again. Mario's running uphill. Just this time it's a little steeper though. We have up 3, right 2, up 3, right 2. If we went down 3, we'd be going to the left 2. And hidden line here, dashed line, because it's not or equal to. So that would go like that, and we're shading below the line. Here's our roof again. We're shading below the line, so it's going to be stuff like this. Now, what is included in both parts, or what's both red and green? I will highlight this here. This part is both red and green right here. So this is my solution set. It could not lie on the green line because it's dashed. That means it doesn't include that line, but it could lie on the red line. So now let's take our points right here and let's see what works of those points. -4, -1. That's going to be here and here. I'm going to plot those points in blue. -4, -1. I meant down here. If I set up here, I meant down here. So -4, -1. Does that work? So I'll put an X through that. That one doesn't work. 3 and 1. It looks like that one, if my graph was perfectly straight, yep, it would still just be inside there. So it looks like that's my correct choice. 0, -3, that's this point right here. That's the y-intercept. So yes, that works for the red line, but remember, it doesn't work for the green line because it's dashed. So it can't be right on the line. To be a solution to this system, to be a point that lies in the solution set for the system, it has to work for both lines. So that one's not going to work. This one didn't work. This one we thought did, but let's check the other ones just to make sure. So I'm going 4 and then 3 up here. Does that work right there? No. So that's on the green line itself, which is dashed. That's why it doesn't work. Choice B is the correct choice. Again, though, I wanted to talk about what it started off by saying that you could, yes, we could plug these values in and see if they worked. So you could have plugged in -4 in for x. That's the x value right here. Be careful. They're kind of trying to trick you there. You could plug that in for x and plug this in for y into both of these. If they worked, if these values worked in both inequalities, then yes, that would be the right answer. If you checked them, they would not though. The only one where they would work in both inequalities would be choice B. So plugging that in, you could use that as an idea, but we really should know how to do this as well. This is the one that worked. This one did not work because it was on the green line. Same thing here. That should do it for that one. Number 7, choice B.